Okay, so today we are now moving forward. Yes, we are. Wait, we didn't do this. No, okay, yeah, good. We are moving forward from our talking about inequalities. And today we're going to be focusing on graphing inequalities, but this time instead of like a single variable inequality, we're going to be talking about inequalities in two variables. So that means before we move on, I'm going to go around to the front of the screen. I'm going to come around up here. I'm going to turn my screen and we're going to get started with this guy here today. So we're talking about graphing inequalities with two variables. And when we're talking about these one variable inequalities, that's like when we're looking at like x is less than or equal to 5, right? Or if we were to say O is greater than or equal to 7, right? We're talking about only one variable here. So when we go to graph it, it's going to be like, it's going to have a solution set that falls on just a single like number line that's in like one dimension, right? So like if we have like 0, 1, 2, 3, right? That was really bad. -1, -2, -3. So like when we're talking about one variables, we would be graphing them on like it's not really like a single dimension. It's like a single dimension in the way that it only has one variable. So we're having like just like a horizontal number line. So now we're talking about inequalities with two variables, and inequalities with two variables are really talking about like x and y, right? So when we go to graph these guys now, we're going to be graphing them like a traditional equation in the way that we have our quadrants here. We have Q1, Q2, Q3, Q4, and we graph them like we would any other line, like something like that. Or today we're going to be looking at some vertical, some horizontal. So we will be graphing these now in the more traditional sense of the word. Does that make sense, you guys? How we're going from one variable, which is when we graph it, it has just our number line. And now when we're talking about two variable, we're going to be talking about graphing it like a traditional equation on a quadrant, on a 4 grid, okay? That's where like the big piece is, and that's why I wanted to take a minute to sort of go over that, because that is where most people sort of get confused, because they're like, Miss, like we were literally only talking about like, why are we going to now graphing on a quadrant when we were graphing, because we're talking about x comma y now, okay? So let's take a look at slide number 2. Okay, so here is an expression, okay? We have the expression 2x plus 3y. We need to decide if the values in each ordered pair, x comma y, make the value of the expression less than, greater than, or equal to the number 12. So basically what we're doing with each one of these ordered pairs is you're taking it to x plus 3y, and you're comparing it to the number 12. And I'm going to put a little box here because for each one of these, you're going to have to tell me which symbol would go there when you plug that ordered pair in. Do you guys see what I'm asking you to do here? Kyle Kelly's already good. Okay, so I want you to take 2 minutes right now to plug each one of these in and make your comparison to the number 12. Okay, take 2 minutes right now. Boom. Thank you, Abby Wasta and Kyle, for being super active participants this morning. I need everyone to be the same way today. Once you get answers, let me know in the chat. I'm going to erase this here. Actually, I'm going to write that back up. 1, 2, 3, 4. 2x plus 3y. And then we're going to do box with the number 12. Nice job, Abby Wasta. Nice job, Gabe. Nice job, Max. Nice job, Peyton. Very good. 30 more seconds, guys. I'm gonna grab Tyler's desk. Awesome job. Thank you, Abby Wasta. Thank you, Gabe. Thank you, Max. Thank you, Peyton. Thank you, Kyle, for giving me answers in the chat. Very good. So if we were to look at the first one here, we would be plugging in 0 for x, 5 for y. When you do that multiplication, you get 0 plus 15 is what? So 15 is what compared to the number 12, and it is very good for everybody on that one. Greater than, very good. I'm going to just sort of rework this a little bit. And then I'm going to write the 15 and then the 12, and it's greater than. Good. Very good. If you didn't get that one correct, make sure you make a change on that one. Now let's look at the next one. We're going to plug 6 in for x, 0 in for y. 2 times 6 is 12. Very good, Gabe. So he got 12 because 2 times 6 is 12 plus 3 times 0 is 0 is less than, or is, no, is equal to, Miss Jermaine, come on, use your brain, is equal to the number 12. Very good, Gabe, on that one. Very good, Peyton. Very good, Abby Wasta. So good. Nice job. Equal to. Nice job on that one. Let's take a look at the next one here. We have -1, -1. So 2 times -1 is -2 plus -3 is, just like Peyton said, -5. And we need to compare that to the number 12. Which symbol did we put in here? Nice job, Gabe. We put in that. Very good, Peyton. Less than. Very, very, very good. Because 12 is, oh, that's the wrong way. Mr. Ming put it the wrong way. Look at me, I caught it. Nice job. Less than. Nice job. Last one here. We're plugging in -5 and 10. And we're going to get, as we compare it to 12, that would be -10 plus 30. And that's going to get us what? -10 plus 30 is... Nice job, Gabe. It's going to get me 20. And then he said when we compare those two numbers, 20 is going to be greater than. Very good. Nice job, guys. So when you're given an expression and you're being asked to compare it to a number, you're going to have to plug those ordered pairs in and test greater than or less than or equal to. Boom. Nice job on that one, guys. Let's take a look at the next bit here. Okay, our learning targets for today, we have 2 of them, okay? They're a little bit complicated in the way that they're worded, so I'm going to break them down a little bit. Given a 2-variable inequality and the graph of the related equation or inequality, I can determine which side of the line the solutions to the inequality will fall. Okay, so we're going to be talking about when we graph an equation here. So let me just sort of give you a rundown, an example here. So when we graph it, for example, that's our equation line. When we talk about graphing a 2-variable inequality, we're going to shade one side of that line. In the way that we choose which side we're going to shade is we need to look for the side that's going to have solutions to the inequality. So say you have 2x plus 4y is greater than 20 or 12 or something like that. So you're going to take a coordinate point that falls above this line. So for example, this is 2, 3. I'm just pulling numbers here. You would take this I'm getting ahead of myself. Take this ordered pair and plug it in. Is it a true inequality? Does that make the inequality true? If you say yes, you're going to shade the region that has the point you just chose. If it is incorrect, you would shade the opposite region. I'm going to get into this more in a moment, okay? So I'm just sort of getting ahead of myself, but I think it's a little bit important to talk about. Okay, next, so we're going to be learning about where we're going to shade. Then we're going to be able to determine the graph that represents the solution to a linear inequality. So first we're going to talk about what this shading deal is, and then you're going to describe a graph when you're given an inequality. Okay, so let's take a look at what we're going to do to get to that point of being able to hit both of these targets. We're definitely going to be able to get there, but it's going to take a step or two to sort of get there. Okay, so let me just move my sharing bar up to the top. Let me scooch myself over a little bit. So we're looking at this slideshow for today. We're looking at slide number 4 now. Okay, and it's called solutions and not solutions. Okay, so your first job here is to identify 3 coordinate pairs that are solutions and 3 ordered pairs that are not solutions to this inequality right here. So my suggestion is you go through and you pick some ordered pairs. Pick from all over pick 6 points from all over your grid, okay? Then plug them in and determine, are they a solution, yes or no? And then if you're missing some, like after you do 6 of them, just sort of figure out what do you notice and then pick another few points, okay? I want you to take 3 minutes right now. Actually, I'm going to say 2 minutes right now to determine some points that are solutions that are not solutions to this inequality. Okay, so I would suggest like picking like from different parts of the grid to sort of get a good idea. Okay, take 2 minutes right now. Nice job, Kyle Kelly. Are all those ones you're listing solutions or not solutions? Oh, okay, nice job, Kyle. Nice job, guys. Give me some coordinates that like say like solution or no solution, and then give me the coordinates. Making sure we're writing coordinates appropriately. With this sort of piece of the grid, there's probably going to be more that are solutions that are not solutions. Nice job, Peyton. Nice job, Kyle. Let's get some more coordinate points, please. Okay, I'm going to sort of color code this. R, and then not. Actually, I'm going to say instead of R, I'm going to say solutions. Hey, I need people other than Kyle and Peyton to put some coordinate points in the chat, please. What are some coordinate points that are a solution? So first, give me coordinate points that are solutions to this inequality. Okay, nice job. Okay, so let's look at some of these first that Kyle said. So Kyle said 3, 2. So that means over 3 up 2. Nice job. So I'm going to, I did all the same color. 1 second. So solutions are going to be red. Okay. So what I want you to do is, for the ones that are solutions, I want you to drop those points, grabbing off of this pile right here. I want you to plot them on this grid along with me, okay? So solutions, he said 3, 2. Good, nice job, Kyle. Okay, Peyton said 6, 0 over 6 up 0. Good, nice job. Gabe said 0, 0. Nice job, Gabe. Max said -2, -2. Okay. Let's see. 8, -8. So over to 8 down, or over to 8 down to -8. Nice job on that one, Max. Another friend in the chat said -3, 6. Over to -3, up to 6. Okay. Ian said 3, 2 as well. Nice job, Ian. We have -5, 4. -5, 4. Okay, and then one more would be -7, 9. -7, 9. Okay, what are we noticing? Let's look at some generalities here. What are we noticing about these points that are solutions? That's okay, Jason. No problem, Junior. Try your best. What are we noticing about these points that are solutions? What are we noticing? What are we noticing? Okay, can I have Abby Wasta, can you unmute and tell me one thing that you notice about these points that are solutions?
I notice that they all fall like if you look, they're all relatively close to one another.
Okay, so like they're like here, like they're all sort of in the same general area. Good. Is there so Gabe said that they have smaller numbers. So I'm assuming when you say smaller, Gabe, you're talking about negatives. Right, Gabe? Payne said that most of them are near the top of the graph. Good. Gabe is saying that all of these negative values are going to be solutions. Good, I like it. Maybe not all of the negatives, but most of them are negatives, right? Good. Nice job on that one. Peyton said that they're near, so some of them are near the top of the graph up here, right? A lot of them are in this bottom section down here, quadrant 3, quadrant 4. Good. The solutions all line up. So some of them line up to create a line like this. Good. Are there any points that are solutions that fall above the line? No. Very good. There are no points, like if you were to take 4, 4, that would not be a solution if you plugged it in. Good. So what are some points that you said were not solutions then? What were some coordinate points that you said were not solutions to this inequality? That's okay, Junior. No big deal. You can just watch, buddy. So who can give me one coordinate point that is not a solution? Can I have, nice job, Gabe. Gabe said 8, 1. Ian, can you unmute? Can you tell me a point that would be not a solution?
I said 8, 0.
8, 0, very good. Gabe said another one, 7, 1. Can I have, let's see, can I have, Tyler, can you unmute and can you tell me one that you thought was not a solution here? What do you think, Tyler? Okay, So we sort of are noticing we're noticing a sort of pattern here. We're noticing that when we draw like this sort of imaginary line in here, the solutions fall below that line and the non-solutions fall above that line. Okay, so maybe we're going to notice something different as we move into the next activity. The second part of this activity is going to be some more independent work. And let me tell you what you need to do for this second piece of the activity here. Okay, so what you're going to do is on slide number 5 is the directions. So on the following 4 slides, there's 4 inequalities. You need to study each inequality and work to do 3 things, right? First, find some coordinate points that represent solutions to the inequality. Find some points that do not represent solutions to the inequality. Plot those points using the coordinates here. So like X's are for ones that are not a solution. The circles are for the ones that are a solution. Okay, so you're going to find some sets of points. Then you're going to plot those sets of points. And then lastly, I want you to plot enough points until you start to see a region that contains solutions and a region that does not contain solutions. Okay, so I'm looking for probably 5 or 6 for each of these. I want you to test out 6 coordinates for each of these. Okay, and then once you go through and you get some of these things, these points plotted, I want you to tell me in this box right here a pattern that emerges. What are you noticing? Okay. And then if you look on here, I have linked in here a, no, I put the wrong thing. I put the wrong link. That's kind of awkward. We're going to a Jamboard. Okay. And you're doing this, you're going to plot some of those points. Green are solution points, red are non-solution points. It's taking mine a minute to load. So each one of the equations each one of the inequalities has its own slide. I want you to, once you get some of your points plotted and you start to write down your patterns, I want you to plot some of your solutions and non-solutions on the Jamboard as well. Okay? So you're going to take, I'm going to give you 7 minutes right now to do these 4 inequalities. Let's get started. If you are unclear on the directions, please put a note in the chat for me so that I know what the problem, where you are falling down. Why did I put the wrong link in here? That's so awkward. I'm going to send you guys the Jamboard link. Give me 1 second. So don't put it on the cohort 4. Just wait for me. I'll send you the link. Just give me 1 second. How did that get messed up? Oh, that's so weird. Jamboard. Loading my jams. Okay, the Jamboard link is in the chat. Okay, so Naseem, if you can't hear me, it's going to be your expectation to join and watch the video after class today to get caught up with what you missed, okay? That is the expectation. I'm going to pull this over to here. Come on, don't be dumb. There we go. There is Sadie. Okay, I'm going to close out the C4. Nice. People are in. Anonymous Elephant joined. Peyton is in. Does that make sense, Naseem? Let me put this in the chat to you. No problem, Missy. Not a problem. Wonderful, wonderful. We just have 3 minutes and 30 left. You're doing great, guys. Okay, I'm seeing some good points put on here. Nice job. Let's see if anybody put anything on slide number 2. Nice. Okay, we got some on slide number 2. Anonymous Tiger. Okay, I got some on slide number 3 as well. Okay, and then people are still working on 4. Nice job. You guys are doing fantastic. Nice job. And if you, when you click on it, if it starts to like spin, just click off of it, and then it will help you. You'll be able to actually like do it. So let me show you. So like if you wanted to like bring this guy over here, and you click on it, and it like starts to spin. Oh no! Click off of it, and then just click and drag. Confidence is key. Click and drag. If it starts spinning, click off of it, and then try to click back on. And that put this one on here. I want you to try it. 4 is greater than or equal to 9. I don't know. Whoever put this guy up here, take another look. Plug the points in and test it. Test the inequality. You need to test the inequality 6 times. Okay, so what I want you to do, there might be a text box behind it. So, which slide are you on, Junior? 5. Okay, 1 second. Well, 5, you shouldn't be clicking on any. Oh, no, 6. Okay. So if you click on here, there might be like a text box behind it. I don't know if there is. So what you want to do is you want to click on it and then sort of, oh, it's making it bigger. Let me try that again. Okay, so you're gonna go over it until like the 4-way little boxes are on it, and then you'll be able to move it. So if you click on it and like you just have like 2 arrows on it, that's not gonna work. It's gonna make it bigger or smaller. You wanna hover over it until you have the 4-way on it, and then you move it. Does that make sense, Junior? Those are a little bit fickle. Nice job. Thank you for reaching out, Junior. Awesome. Okay, listen, not a big deal if you didn't get through all of these. We're going to start to take a look though. So here we go. Some solutions on this first one here. Here we go. I'm going to go a little bit quick on this one. Just sort of as because we can. So you're going to come over here for solutions. Are going to be this guy here, because you're plugging in a value for X, plugging in a value for Y. So is 4 greater than 2? Yes. Is 4 greater than or equal to 4? Yes, it is. So you would have a point there. You would have a point here. You would have a point here. You would have a point. Oh, Mr. May, don't do that. You would have a point here. Let's try that. We would have a point here. Any point under here would work. You're plugging in points here, 6, 6, and you're saying any number that falls below this line here, this sort of invisible line here, would be a solution. Okay? So all of these numbers that fall below here are going to be solutions. Some non-solutions, nice job, Kyle Kelly, would be a point here, 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 boom, boom. There we go. So non-solutions I did as green, solutions I did as blue. So you're going to be plugging these, you're plugging random coordinates in, and you're deciding, does it make it true? Yes or no. Okay, very good. Now, if we look at this second one here, this one's a little bit different because we have a, we actually look at it and it's a y equals, so like if we converted this to an equation, it would be -2y equals -4, right? And then we would divide by -2. Actually, but I'm going to keep it as a symbol here because I'm going to say -2y is greater than -4. Divide by -2, divide by -2. Y is less than 2. So if you're looking at some solutions here, it's going to be, since it's a y equals, we know it's going to be a horizontal line because it's crossing the y-axis. Some solutions to this, because we have is greater than, we're not going to have any points at the number, let me just find my thing here. We're not going to have any points that fall on the number 2. So it's going to be like this point right here, this point right here, this point right here, down here, all along this sort of demarcation line of y equals 2. Along this equation line of y equals 2, everything that falls below that line is going to be a solution. Everything that falls above that line would be a non-solution. If we start to talk about, we're going to talk in the afternoon video about shading. The shading is going to come in. You're going to shade the region that has the solutions that fall in it. If you were to shade this equation here, you would be shading down here. Okay? If we were looking at slide number 8, this one is an x is equal to, if we were to convert it to an equation, and that means it would be a horizontal, a vertical line at the number 3. And solutions would fall on this side of our line. Non-solutions would fall here. So I would have to shade over here. I go into some really good detail on this in the video for the afternoon. So don't stress if you're like, whoa, miss, I don't understand. And we're doing a review of this again tomorrow. So last one here, we have the same equation of, or similar, it's x plus y is greater than 10. Okay, this one was a little bit smaller of a region here. We would have a point at here. We would have a point here. And this is our little sort of demarcation line. If we were talking about the equation, if we were to convert this to an equation, our demarcation line would be where all these blue dots are. The solutions, are the solutions gonna fall below that line or above that line? Is it gonna fall in the red region? Or are the solutions going to fall in the green region? Tell me in the chat. Are the solutions for this one here going to fall in the red region below the line or the green region above the line? Nice job, Peyton. Nice job, Junior. If I were to take this equation here and I pick a point here, this one is 9, 5. Plug that in. 9 plus 5 is greater than 10. 14 is greater than 10. Nice job, Junior. Nice job, Gabe. Nice job, Kyle. Nice job, Peyton. Nice job, Junior. It would fall in this green shaded region up above. Okay, I talked a lot about this in detail in the video. The video is a little bit longer today, but I need you to give me all of the time for that video. It's a very important video. We're making a big jump from yesterday to today. We are going to review this again tomorrow, but I need you to watch the video, okay? So for this afternoon, you don't have to do anything on 1. You don't have to do anything on 10, 11, or 12. You're going right down to 13. I linked the video in here. You're going to be completing 3 slides, really, 3, like these ones here. I do a little bit of talking on this one, but 15, 16, and 17, you are going to be working on. The recent grades are going to go in today. I just got a little bit behind, and today is my makeup day. Okay? Does anybody have any other questions for me? No? Okay, so if you don't have any questions for me, let's phrase it like this. If you don't have any questions for me, you can head out to science. If you do have questions for me, you can stay in and ask. I will see you all tomorrow, guys. Nice job today. Bye, Tyler. Bye, John. Hi, guys. Give me 1 second.